Welcome back, algebra students, to Wes Explains Best. We're going to be talking about 7.4, division properties of exponents. So we just got talking about raising a power to a power. In the first section, or second section, we talked about multiplying like bases. Now we're going to be talking about something a little bit different. So first, let's consider the problem, the first example, 5 to the fourth power divided by 5 to the second. What does that mean? Well, one way we could write it is we could write it out numerically, so we could calculate what 5 to the fourth power is. So that's 125 times 5 by my recollection, so that's 625, and divide that by 25, and we could get an answer that way, which equals 25. Okay, that's one way to do this problem. Or what we could do is we could set it up into a fraction. So we could say 5 to the fourth power. Let me change this to red. We could say 5 to the fourth power divided by 5 squared. Okay, and that's what we're going to demonstrate over here. So here we write it as a fraction, 5 to the fourth over 5 squared. And what 5 to the fourth power means 5 times 5 times 5 times 5. 5 squared means 5 times 5. So now what we can do is we can cancel out what we see in the top and the bottom. Anywhere where there's a 5 in the top, we can cancel out with a 5 in the bottom. So 5 we can cancel with that 5. 5 we can cancel with that 5, and what are we left with? Well, it just doesn't become 0. That's a common mistake. It becomes 1. Why does it become 1? Because essentially this becomes this problem. 5 over 5 times 5 over 5 times 5 over 1 times 5 over 1. That's another way to rewrite that. So essentially those 5's in the bottom cancel with the in the top, and we're left with 1 in the bottom. Okay, so that's why that is. For anyone that's confused on canceling, there you go. That's how you can cancel. What are we left with on the top? We're left with 5 times 5, or 25. See how we got the same answer? Okay. Now, there's another way to do this problem. Because 5 times 5 is the same thing as 5 squared. So 5 times 5 is the same thing as 5 squared. So how do we go from 5 to the fourth divided by 5 to the second and get 5 squared? Is it a coincidence that these exponents are all related? How are they related? Let's do one more example to figure that out. So the long way to do these problems is to simply write out 3 times 3 times 3 times 3 times 3 times 3, that's 6 times 3, that's 7. So I wrote it out 7 times 3 times 3 times 3 times 3, that's 4 times. And now I can cancel. Cancel, 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 cancel. Cancel, cancel, cancel. 4 on the top with 3 on the bottom. 4 on the top with 4 on the bottom, leaving us 3 on the top. 3 times 3 times 3 is the same thing as 3 cubed, is the same thing as 27. Now, I did that really fast, and the reason why I'm showing you is because there's a better way. How do we get 3 to the third using a more efficient method? Well, anytime we have division of exponents, we can subtract the powers. So 3 to the seventh divided by 3 to the fourth, we subtract the powers and we get 3 to the third. So 7 minus 4 equals 3. So that's how we got this up here. 5 to the fourth divided by 5 to the second. 4 minus 2 gives us 2. So that's what we do with exponents. So now we have another example. We have 2 cubed over 2 to the fifth. In this case, we're going to do the same thing. We can do 3 minus 5. So 2 to the third divided by 2 to the fifth. We subtract exponents, and we should get 2. Well, we have to the 3 minus 5 equals 2 to the negative 2 power. To rewrite 2 to the negative 2, we get 1 over 2 squared. To make it a positive exponent, you move it to the bottom of a fraction, okay? So how do we get 1 over 2 squared or 1 over 4? How did we get that? Well, we could also do it this way. So 2 times 2 times 2 in the top. Let me get rid of this extra. Divided by 2 times 2 times 2 times 2 times 2 in the bottom. We cancel out 3 of the 2's in the top with 3 in the bottom. And we're left with 2 in the bottom. 2 times 2, 1 over 2 squared, 1 over 4. So we get the same thing. So that's why we can subtract exponents. This is going to be critical. We can subtract exponents when we divide, okay? So dividing powers, a to the m divided by a to the n, we get a to the m minus n. And that's our first key point. So let's do a couple more complicated examples. So we're going to do the same process here. Because they have the same base, it's very important. They need to have the same base. We can subtract exponents. So we know this is going to be exponent of x, and then we just do 3/2 minus 2. Well, we need to find a common denominator here, very common. So we're going to multiply the 2 by 2. So we can have a common denominator, and we get -1/2. -1/2. If we wanted to, we could rewrite this as a positive by writing it in the denominator of a fraction. Either of these are good unless it specifically asks for a positive exponent. Now we have a problem here where we could, this is the way I just showed you, is we do 5 to the 2 minus 5 times n to the 4 minus 3. And you get m to the -3 times n to the +1. And if you wanted to write it as positive exponents, you could have n on the top. In order to make the m a positive exponent, you need to move it to the bottom of a fraction like that. The way I like to do it, though, personally, is I do it like this. I look here and I see that 2 of these m's, the 5 is bigger, so both of those m's in the top are going to cancel with 2 in the bottom, leaving 3. The n's are bigger in the top, so all 3 in the bottom are going to cancel with 3 in the top, leaving you 1. 4 minus 3 is 1, so it should be n over m cubed, and that's the answer. So there's 2 different ways to do it. I like the way in purple I just showed, but most people I've found, despite my my convincing or trying to convince, is this way, where they just subtract exponents. So moving on to C, we have the same process here. So I'll do C using my way and D using the other way. So to do C, we could cancel, well, there's nothing to cancel. There's k to the 0 gets canceled. It essentially goes away because it's the same thing as 1. So that kind of cancels off on its own, but we could cancel 2 of these j's with 2 of those j's, leaving us 3 j's. So then we should have k to the 6 over j cubed. Let me just double check that using your way. I kind of lied, I'm sorry. K to the 6 minus 0, 6 minus 0, and then j to the, what was this number? I forgot. This was 2, and that was 5. Okay. J to the 2 minus 5, so we should get k to the 6, and then j to the -3, and that's what this is up here. Okay, so we got the same thing. Now, when it comes to my method, you would have to move this first before. So actually, the method where you just subtract makes it kind of easy, okay? So here we have a to the -3 minus 5, and then b to the 7th minus a -2. Don't forget to keep the -2 in parentheses. So this problem becomes a to the -8 times b to the 9th power. If you wanted to rewrite this as a fraction, you could have b to the 9th power over a to the 8th, and that's our final answer. Only a few more examples left, so let's go ahead and finish this off. Here we have a power to a power, so we need to multiply exponents. This is like in our previous section. So 3 times 3 gives me 9. Then we have 2 to the 3rd power in the bottom. So we have x to the 9th over 8. That's another way. So that's a pretty straightforward problem, and it's just kind of division there, but really there was nothing in the top and bottom that had the same base, so we didn't need to subtract anything. So this kind of proves our next point, though, raising a quotient to a power. We can make a to the nth over b to the nth, okay, which we demonstrated in this step right here. Last but not least, we have these two examples. So we're going to first raise power to a power for both these. That's what I like to do. So I have z to the 2 over 3, and I multiply by 3 over 1 over 5 to the 3rd power. So I multiply these exponents together. I get z to the 6 over 3, or z squared, over 5 cubed, which is also over 125. That's my first answer. And over here, I'm going to raise everything to the -3 power. So I get 2 to the negative 3 times x to the multiply power times power, multiply negative 18 over, another power times power. I get 4 times negative 3 is negative 12. So I have a lot going on here. Now, I'm going to show you how to make these positive exponents. So this would be okay, but personally, if I was your math teacher, I'd say write it as positive exponents. So first thing I would do is anytime you have a negative exponent at the top, it needs to move to the bottom. So both these are going to move to the bottom. But anytime you have a negative exponent at the bottom, it moves to the top. So it would look like this. The negative y to the negative 12 becomes y to the 12 from the top. 2 cubed in the bottom, it becomes x to the positive 18, it becomes. And then finally, you could simplify further. Y to the 12th over 8, x to the 18th, and there you go. Hope you guys found this helpful. We're going to do more practice a little bit later on. Until next time, be good, be kind, be true, be nice, be honest, and have a great day.